The distributorless ignition system is designed to replace the mechanical distributor system, HEI, in controlling the ignition coil secondary coil voltage. In a distributorless ignition system, a spark plug is attached to each end of the ignition coil secondary. Each coil secondary fires the plugs in two companion cylinders that reach top dead center, TDC, at the same time, compression and exhaust. Since polarities of the ignition primary and secondary windings are fixed, one plug always fires in a forward direction, while the other always fires in reverse. This arrangement requires somewhat more energy than conventional systems where all plugs always fire in the same direction. No ignition coil is designed to be run with the secondary unloaded. This is particularly true with distributorless ignition systems. However, the high voltage produced by these systems can cause personal injury and/or equipment damage. Since both plugs in companion cylinders fire at the same time, it is not necessary for the module to recognize which cylinder is on which stroke. Because of lower pressure in the exhaust cylinder, the plug on the waste cylinder requires less voltage to produce an arc. Therefore, most of the available voltage is used to fire the plug on the compression cylinder. With the exception of the 3800 engine with the fast start system, during initial startup, the ignition module first energizes the coil that fires the second cylinder pair that reaches top dead center in firing rotation. The new breed of General Motors vehicles are equipped with state-of-the-art DIS, C3I, or IDI systems. To successfully diagnose and repair these sophisticated systems, you must have the approved diagnostic procedure, test equipment, and system operating knowledge. The components that will be featured in our test procedures include an ignition module, ignition coils, crankshaft sensor, camshaft sensor, and an interrupter. Distributorless ignition systems used on 3.0, 3.8, 3300, and 3800 liter engines are referred to as computer-controlled coil ignition or C3I systems. All C3I systems use a coil pack, an ignition module, and various types of camshaft and/or crankshaft sensors. C3I systems used on these engines are designated Type 1, Type 2, and Type 1 Fast Start. The distinction between Type 1 and Type 2 is the arrangement of the coil pack. On Type 1 systems, 3 coils are contained in a single molded unit, while on Type 2, the coils are individually serviceable. Our objective in this video is to inform you about the diagnostic procedures and to train you in the proper use of the test equipment. We assume that you already possess a basic working knowledge of General Motors' computer command control systems. If you're not familiar with the C3I system, refer to the NAPA Eklund tape entitled Troubleshooting and Diagnosing GM Computer Command Control Systems. The vehicle that we will be testing is a 1991 Buick Park Avenue with a 3800 engine. Before we begin the diagnostic procedures, there are a few precautions that must be taken to ensure the safety of the tests. First, the parking brake must be applied, and the gear shift must be placed in park. An exhaust hose is then attached to the tailpipe, and a wheel chock is placed behind a rear wheel to prevent accidental movement of the vehicle during testing. The engine coolant temperature must be at normal operating temperature, 195 degrees or higher, before any diagnostics can be performed. The Service Engine Soon or check engine light should be functional when the ignition is turned to the on position. After starting the engine, the Service Engine Soon light must turn off and remain off. If the Service Engine Soon light remains illuminated, this would indicate that there are existing service codes stored in the ECM that must be diagnosed and repaired before other tests are performed. Use of the Service Engine Soon light enables you to retrieve service codes from the ECM by jumping the assembly line diagnostic link, ALDL connector. In order for you to be able to read the sensor information received by the ECM or output to the actuators by the ECM, you must use a scan tool that is designed to interface with General Motors systems. The scan tool uses vehicle power, either by plugging into the lighter or connecting directly to the battery, and is connected to the ALDL connector by a cable connection. You must then program the scan tool to the particular system and model of vehicle to obtain correct interface with the system. This is accomplished by the scan tool asking for information on the vehicle and then entering this information. With the engine off, you can now scroll the scan tool for system serial data and record this information to be used later during system diagnostics. You will be able to read each sensor input to the ECM and ECM output by scrolling. In order to receive a clear picture of the system's operating capabilities, you must read the sensor inputs while the system is operating under normal conditions, engine running. Before attempting to read serial data, make sure the engine coolant is at operating temperature. The oxygen sensor is operational, and that the Service Engine Soon light is functional. At this point, scroll the scan tool through each mode and record the sensor input and ECM outputs for use in later diagnostics of the system's operation. It is very important that you record serial data in both the key on, engine off, and key on, engine running modes to receive a clear picture of the system capabilities and operating status. Before beginning any diagnostics, the battery must be tested for voltage. Use a digital volt-ohm multimeter and using the DC voltage scale, measure battery voltage. The reading must be between 12 and 13 volts for the system to operate properly. Compare the reading with the specification in the Diagnostic Manual Test Procedure. You can now check individual system operation capabilities by using a diagnostic manual and the serial data that you recorded earlier with the scan tool. The camshaft position sensor is located in the front of the engine block behind the water pump pulley. The next step is to disconnect the connector from the sensor as shown here. Then, using a diagnostic manual, you must find the test applicable for the cam sensor. During cranking, the ignition module monitors the dual crank sensor synchronization signal. The synchronization signal is used to determine the correct cylinder pair to spark first. After the synchronization signal has been processed by the ignition module, it sends a fuel control reference pulse to the PCM. When the PCM receives this pulse, it will command all 6 injectors to open for 1 priming shot of fuel in all cylinders. After the priming, the injectors are left off for the next 6 fuel reference control pulses from the ignition module 2 crankshaft revolutions. This allows each cylinder a chance to use the fuel from the priming shot. During the waiting period, a cam pulse would have been received by the PCM. Now the PCM begins to operate the injectors sequentially, based on true camshaft position. However, if the cam signal is not present at startup, a code 41 will set and the PCM will start sequential fuel delivery in random pattern with a 1 in 6 chance that fuel delivery is correct. Conditions required for code 41. Engine is running. Cam signal is not received by PCM for last 5 seconds. To begin the test, with the key off, disconnect the cam sensor harness connector from the cam sensor. Turn the ignition to key on, engine off setting for this particular test. Using a digital volt-ohm multimeter, measure voltage between the harness connector pins AB and BC. The reading for AB should be between 5 and 7 volts, and the BC reading should be between 8 and 11 volts. If the readings fall into these specific areas, then you may proceed on to the next step in the diagnostic flow chart if code 41 was present. There is also a chance that the reading will not be within specifications. If this is the case, refer to answer no and proceed to the next diagnostic chart box referred by the no answer. Refer to the diagnostic manual for this test, which will determine if the ignition control module is receiving correct battery voltage to operate properly. To prepare for the test, loosen the module connector bolt and remove the harness connector from the module. Then, using a digital volt-ohm multimeter on the DC volt scale, measure voltage at pin P, the pink black wire on the connector. You must see the battery voltage that was recorded earlier when testing the battery. If the reading is not the same, then you must follow that circuit and locate the area that is causing the problem. For instance, connector corrosion, short in circuit, open in the circuit, and so on. The next test is to be done on the manifold air temperature, MAT, sensor. To begin, locate the MAT sensor in the air cleaner assembly and open the diagnostic manual to code 25 for proper diagnostic procedure. The intake air temperature sensor is a thermistor. The PCM applies a voltage of about 5 volts to the sensor. When the air is cold, the resistance is high, and the PCM will measure a high signal voltage. If the air is warm, the sensor resistance is low, causing the PCM to measure low voltage. Code 25 will set if signal voltage indicates an air intake temperature greater than 103 degrees Celsius, 218 degrees Fahrenheit. If vehicle speed is greater than 35 miles per hour, or if both of the requirements are met for at least 5 seconds. Code 25 does not illuminate the service engine soon light. The test procedures are as follows. Install the scan tool. Make sure the ignition is in the key on, engine off position. Now observe the manifold air temperature, intake air temperature on the scan tool. The scan tool should display a temperature below 103 degrees Celsius, 218 degrees Fahrenheit. Does it? Yes or no? If the display does not fall within this temperature range, then proceed to the next chart following the arrows after the no answer. At this point, you'll be asked to disconnect the IAT sensor. Then observe the IAT temperature on the scan tool. It should read -40 degrees Celsius, -40 degrees Fahrenheit. Does it? Yes or no? If the answer is yes, then you have a faulty IAT sensor and it must be replaced. After you have installed the new component, retest. To begin the testing on the throttle position sensor, locate the throttle position sensor on the throttle body area of the intake manifold. Then open the diagnostic manual to code 21 for proper diagnostic procedures. The throttle position sensor, TPS, provides a voltage signal that changes relative to throttle blade angle. The signal will vary from about 0.4 volts at idle to about 5 volts at wide-open throttle. The TPS signal is one of the most important inputs used by the PCM for fuel control and for most of the PCM control outputs. The test starts by installing the scan tool. Make sure that the throttle is closed. Does the scan tool display the throttle position over 2.5 volts? The next step is to slowly move the throttle to wide-open throttle position, and at the same time, you should see the reading move smoothly to approximately 5 volts. If either of these two actions does not meet specifications, then follow the flow chart to the next procedure. The next test is a coil test or cylinder balance test. To begin, install rubber vacuum hose between the coil terminals and the spark plug wires. Then, with a tachometer attached and engine running at normal operating temperature, check for weak cylinder operation in the ignition system. Use a non-powered test light with one end connected to a good ground, and then proceed to touch each piece of hose and observe RPM drop. The correct drop is approximately 100 RPM change per cylinder if the system is functional. The next test is the crankshaft sensor test. To begin this test, locate the crankshaft sensor. It is better accessed from under the vehicle. The C3I fast start system on the 3800 engine uses a dual crankshaft sensor and a separate cam sensor. Advantages of the fast start system are faster startup, walk-home protection in the event of cam sensor malfunction, and more precise measurement of crankshaft sensor signals. The 3800 dual crank sensor is mounted on the front of the engine beside the harmonic balancer crankshaft pulley. The arrangement of the interrupter rings on the harmonic balancer is different than on other V6 engines. First, the outside ring has 18 evenly sized and evenly spaced interrupter blades to produce 18 pulses per crankshaft revolution. These pulses are known as the 18X signal. The inside ring has 3 interrupter blades with gaps or windows of 10, 20, and 30 degrees. These gaps, in turn, are spaced 100, 90, and 110 degrees apart, respectively. These pulses are referred to as the 3X signal. With this interrupter ring arrangement, The ignition module can identify the proper cylinder pair to fire within as little as 120 degrees of crankshaft rotation. The module can also fire any cylinder pair reaching TDC first without waiting for the cam or sync signal. Since the module does not need a cam sensor toggle to set up, the engine can start and run with a failed cam sensor. To start the test, disconnect the crankshaft sensor harness connector from the crankshaft sensor. Turn the digital volt-ohm multimeter to the DC volt scale and open the diagnostic manual to the proper test procedure. First, touch terminals A and C on the crank sensor harness from the PCM. The voltage reading should be 9 to 12 volts. Is it? Yes or no? Next, check voltage between harness terminals B and C. Once again, the voltage reading should be between 9 and 12 volts. Is it? Yes or no? If either readings are not within specifications, follow the flow chart to the next section until the problem area is isolated. Repair as necessary, as instructed by manual procedures. The IDI system is different from other distributorless systems because it has coils mounted in a housing which connects to the spark plugs. The coils and ignition module are mounted on an assembly which mounts between the camshafts on the Quad 4 system or attaches to the camshaft cover on the single overhead camshaft engine. In order to test the IDI-type coils, it will be necessary to remove this cover. Once this is removed, insert spark plug jumper wires between the coil connectors and the spark plugs. Refer to the manual for specific test specifications and procedures. The IDI system used on 2.3 VIN code A, D, and 3 engines uses a different type of crankshaft sensor. This system and other Type 2 systems use a variable reluctance type crankshaft sensor. If a no-start condition is encountered, it may become necessary to test this sensor. This type of sensor mounts through the side of the engine block. The crankshaft has an integral interrupter ring, which is similar in design to the older style systems which had a timing coil integral to the distributor shaft. The variable reluctance type crankshaft sensors can be tested in the same manner as the older GM distributor magnetic pickups. First, locate the sensor and disconnect the wires. Connect an ohm meter to the 2 leads and measure the resistance. Refer to the manufacturer's specs and replace if required. This concludes our clinic on the distributorless ignition systems. Hopefully, this presentation has better prepared you to diagnose and service vehicles equipped with this system. We hope that you will join us again for another in the series of NAPA ENunn technical videos.
Well, that concludes our clinic for tonight. I'll be glad to stick around for as long as you guys have questions. Yeah.
Well, how about it, Charlie? Aren't you glad you came with me tonight?
Oh, you bet. That guy's terrific. He really knows his stuff.
I told you you'd get something you could use tomorrow on the job.
Oh, right, but things are changing so fast. It's tough to keep up.
Without these clinics, videotapes, and manuals from the manufacturers, we couldn't.
Hey, don't forget our ASC certification, too.
That's right. This insignia really means something to the customers that bring their cars to our shop.
You can become one of the hundreds of thousands of automotive service professionals who wear the ASE insignia with pride. A symbol that tells your customer and your employer that you paid the price in study and hard work to master your profession. Whether it's automotive, heavy duty, or auto body and paint, there's a certification program for you. And there's plenty of training available to help you prepare for ASE's written exams. So don't wait. Contact ASE today for more information. There's an ASE insignia waiting for you.